tolerance by default, and this is the projection method symbol. This is the symbol of third angle projection method, which is represented over here. Here name of company, name of component, that is cover plate, number required, that is 4 cover plates are required, materials, the specification is AISI, scale 1:2, 1:2 scale is used over here, so it is a reduced scale. Date on which it is drawn, it is written over here. It is drawn by this person, checked by this person, and this is the drawing number. This is the method of projection method. Assembly drawing. Now what is assembly drawing? Types of assembly drawings. First is exploded assembly drawings. The parts are separately displayed, but they are aligned according to their assembly positions and sequences. Second is general assembly drawings. All parts are drawn in their working position. And third, detail assembly drawings. All parts are drawn in their working position with a completed dimensions. We use this general assembly drawing. All parts are drawn in their working position. Now first, exploded drawing. It's a pictorial representation of the components, and this is the finished product. This is one example of a table. You can draw all these components like this. This is a pictorial representation of the components. So this is the upper layer or tabletop. This is joiners, then wood screws, the wood plate, paper rest. This is the pivot rail. This is the legs, bottom cross rail, and strut. So all these components you can draw in this way also. For a normal human being, this would be easier to use or easier to understand, but in case of engineering, this practice is not used, because the detailed or internal dimensions and orthographic views cannot be drawn over here, which are most widely used in engineering terms. So in pictorial representation of the assembly, this is the detailed drawing and this is the finished product. After assembling all these components, this will be the final assembly. Now second exploded assembly is this one. Orthographic representation. A friction plate, here note is mentioned. A friction plate uses 3 clutch disc units with 4 clutch discs on a friction plate. This is a lock washer, mounting hook. They are mounted like this, and this is one exploded assembly drawing. Now general assembly. This is the pictorial representation of general assembly, and this is the orthographic representation of the same assembly. And number of parts or parts are numbered with some sequence, say part number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, and they are numbered like this. No any dimension is inserted in this general assembly. Only the number of component, even name of component is also not inserted over here. Only numbers are inserted so that the picture or drawing become easier to understand. Another general assembly. This is the general assembly. Only dimensions relate to machine's operation are given. All the dimensions are not needed over here. Only those dimensions which relate to the machine's operation are mentioned over here. For example, in this machine, these are the parameters: width of the table, maximum height and minimum height of this drilled are to be inserted over here. Only dimensions relate to machine's operations are given in the tabulated form as shown over here. In this case, the dimensions are not inserted, but the parameters are used, say A, B, X, K, D1, G, E, S, W and C. In all these dimensions are to be written in the tabulated form, and from the table we can find out these parameters. What's the length, width, and what's the meaning of S and so on. This is another drawing of general assembly. This is number of component 1, 2, 3, 4 and the name of components. So number 1 is tailstock back. So this is tailstock back. Number 2 is spindle. This is number 2, that is spindle, and so on. So there are 14 components. This is the front view, this is side view, number of components and title block. So this is one assembly drawing of tailstock. Another working drawing of assembly. Now required information in general assembly drawings. All parts drawn in their operating position. Part list, or it is also called as bill of materials or BOM, needs to be inserted in the drawings, which includes the item number, descriptive name, material, quantity required per a unit of machine or quantity, leader lines with balloons around part numbers, and machining and assembly operations, and critical dimensions related to operation of the machine. All this information are to be mentioned in general assembly drawing. Now placing an information, how to place assembled parts and reference numbers are to be put over here. General notes, title blocks, part list. This is just an outline how to place the various things on a drawing sheet. Now first, part list, or it is called as bill of material. Locate above or beside the title block. It is general practice to locate the bill of material above the title block or beside the title block. Fill the table from bottom to top. In reverse manner, they are to be written like this. You should draw from the bottom, draw a table like this. First is the serial number or number, then part name, then required quantity, material and not. They should be written over here. And first component should be written like this. Say for example here the name of first component is support. 2 components are required, so 2 should be written over here, and material for that component is cast iron, so which is written over here. Draw a line. Second component is shaft. 1 quantity required, made up of stainless steel. Third component is set screw. Component required is 1, and material is stainless steel. M3, hex, SOC, CUP, PT. These are the abbreviations used and mentioned in the standards. Another example of bill of material. If bill of material can be placed over here also. If the space is not allowed, you can draw bill of material from top to bottom like this. Now steps to create assembly drawings. First step, analyze the geometry and dimensions of all parts in order to understand the assembly steps and overall shape of device or machine. That is the first step. You have to analyze the geometry. The second step, select an appropriate view. Which view would be more usable or more clear to the viewer. And the third thing, choose major parts, which is the main part or major parts, that is parts that have several parts assembled on it. It should be selected. The fourth one, draw a view of major parts according to a selected viewing direction. Then add detailed view of the remaining parts at their working positions, apply section techniques where relative positions between adjacent parts are needed to clarify, and add balloons or knots and dimensions if any. If needed, you can add all this and create bill of material. So these are the steps used to create an assembly drawing. In general practice, the number of views can be 1, 2 or 3 or more as needed, but it should be minimum. We have discussed about these in detail in multi-view representation also. In some cases, one view is enough to represent the detail of the component, then it's okay. You can draw only one view, but it should be minimum. A good viewing direction is that represents all or most of the parts assembled in their working position. That is the good viewing direction. So you have to select that direction from which most of the components or most of the parts assembled in the working position are to be represented. Now one example, selection of a necessary views. Part A is this one, 2 views are given. This is part B. Student A draw this one. If you assemble these two components, this part B is to be inserted in this view. Here this is the hole, so its side view would be this one, and student B represent like this. This is inserted, this component part B is inserted over here, and this is part A. Now think about student A and student B. Which drawing conveys much fruitful and useful details, B or A? Yes, of course, student B shows the better representation of this assembly, because in this assembly these details, the length of this part B is not clearly visible. Here both the parameters are clearly visible, so this is better. So in this case, this is the appropriate view for assembly drawing. General practice, hidden lines usually omit unless they are absolutely necessary to illustrate some important feature that the reader might otherwise miss. So as far as possible, hidden lines are to be omitted, but can be used only when it's necessary. Now this is an example about hidden lines, omit or not. Think about this assembly, part A and part B. A. Suppose both these components are assembled together, this assembly would appear like this. This is the component, here is the hole, and this hole, in this hole this part can be inserted, so assembly would appear like this, right? Now second possibility, B. You can draw like this also. Here hidden lines are omitted, here hidden lines are there, and in C, here hidden lines are shown up to this only. So according to the requirement, which is necessary, A, B or C? Of course B is necessary, because here hole is drilled. If this hole is not drilled, then B would be the better representation of this assembly drawing. So I hope it's clear when you have to omit the hidden line and when the hidden lines should be represented in the drawings. Now second case, part A and part B. Here hidden lines are there, whether they are to be omitted or not. So for that, this is part A, draw part A, and part B is to be inserted in this like this. Assembled B. Now think about these two cases. Here hidden lines are omitted, here hidden lines are drawn. So here it's not needed to draw this hidden line. So in this case we can omit these dotted lines or hidden lines. It's not compulsory to draw these two lines because it's obvious that here object would be there. Section technique is usually need to clarify the mating of parts. In assembly drawing, this is also correct. If we assemble these two components, it would appear like this. But this is better representation. Use different section line styles for adjacent parts. Here technically it is right, but it gives wrong impression. It doesn't clearly mention that these are two components. So to represent that both are different components, we use the sectioning line. One section lines in this component and another section lines in these components. Suppose if we eliminate the color, this is the drawing which shows the better representation of this assembly as compared to this drawing. This drawing shows only one component, whereas this gives the better representation of the drawing. You can see here, without color it would appear like this, and with color it would appear as shown over here. So this is a better representation. Now section line practice. Do not draw section lines on sectional view of standard parts, say thread fasteners, washers, longitudinal cutoff, solid shaft, pin, key, etc. In these standard parts, section lines should not be drawn. Now assembly steps. This we have seen how to assemble this component. Insert this component like this. Three components are there. Put this component, this pin over here, insert this pin over here. It will be inserted in this type, and this is the assembly of these components. Now second example about section line practice. Now if this is the component which is an appropriate full section view of this assembly, if this is the assembly which is good one, A and B